The next question was question number 3. For this question, we were asked to look for values of x which satisfy this equation, knowing that x is a real number. What was the skill that you had to learn here is the idea of absolute of a value. So normally in early stages of secondary school, you already learned that, for example, the absolute of -2 is 2. Absolute of 2 is 2. Actually, this is 2 because we are saying the absolute means put minus to what was inside, and that's why it becomes 2. So to take the absolute of a negative number, multiply the negative number with a minus. We borrow that idea to use here. You could also just square both sides of this and solve the equation. That's a possible way that was there, but it misses the point of what I really wanted. We will have the same results, the same answer, no problem. So in order to take that, we will say, okay, I'll write this expression, my equation, x squared is equal to 1 minus x. Case 1. If this inside, because x is not known, so I don't know if it is negative or positive, but I just follow the rules. If 1 minus x squared was less than 0, that means it was negative, then the absolute of 1 minus x squared means minus 1 minus x squared. That is that. So I will replace this left hand side with this expression. So my minus into 1 minus x squared is equal to 1 minus x. If I open this, I get minus 1 plus x squared is equal to 1 minus x. I arrange them properly, then this is x squared minus x becomes plus x when it crosses to this side. And then this positive one becomes minus 1 and becomes minus 2 equal to 0. So I'm taking things this way. X squared is here, minus x becomes plus x as it goes over, and this also becomes minus 2. So we can use our technique of factorization we saw in the first question of the quiz. So this is xx. I need 2 factors of minus 2 such that the sum give me a positive number. So I'll take positive 2 and minus 1. If I try that, you see it works. 2 times x is 2x, minus 1 times x is minus x. 2x minus x is just 1x. So these are my factors then. So this is x plus 2 multiplied by x minus 1 equal to 0. If 2 numbers multiply to give 0, it means either one of them would be 0. So that means either x plus 2 is equal to 0 or x minus 1 is equal to 0. That means x is equal to minus 2 or x is equal to 1. We look at the second case. Case 2. If 1 minus x squared was positive, then the absolute of 1 minus x squared does not change. It's just 1 minus x squared. That's the rule. So it means that in this my equation here, my left hand side will replace just 1 minus x squared. So I get 1 minus x squared is equal to the right hand side, that is 1 minus x. If I play again, arrange this time, I'll take things to my right so that the coefficient of x squared is positive, just being nice. So 0 here is equal to minus x squared. This way becomes x squared. This is plus 1. If it comes to become minus 1, when this plus 1, they fall off. And I'm left only with minus x. I can factorize x because it's common there. So this is x into x minus 1. So if these two multiply to give 0, it means either x is equal to 0 or x minus 1 is equal to 0. That means x is equal to 1. We already saw that. So it means x, the possible values are minus 2, 0, and 1. That was 3. So you have to choose 3. So 3 was G. So G was answer 3 for this. Of course, I said an alternative would be just square both sides of this. But you see, you start running in powers. Your powers of x start going up. This looks for me a bit easier, that we never get x to the 4. But the other one is also still possible. The fourth question, we have to look for the number of real roots of this equation. So my equation is beta squared x squared plus beta x plus 2 equal to 0. In this expression, it was important. This is an quadratic equation, so we can actually apply the general quadratic equation formula if we want to actually get some information about the roots, considering that we don't have true coefficients here. So the general equation formula is usually written from x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a for an equation that is of the form ax squared plus bx plus c equal to 0. So that means if we recognize that, we can also look for our a, our b, and our c's. What is special about this thing under the square root sign is that the square root of a negative number is not defined in the real environment. So it means what is inside there determines the type of roots that you will have. So this part we usually call the discriminant because it discriminates between those roots. So I will call it d. So my d is equal to b squared minus 4ac. This discriminant tells me what are the things. For example, if the discriminant is strictly positive, it means I have two values of x that are distinct. If it is equal to 0, it means I have two values of x but they are identical. If it is less than 0, it means that the root is not possible within the real environment. So if this is true, then from here, my a there is beta squared, my b is beta, and my c is 2. So this is going to be b beta squared minus 4 times a is beta squared times c, which is 2. If we do that, that is beta squared minus 2 times 4 is 8. 8 beta squared. Beta squared minus 8 beta squared is 7 beta squared. If you look at this, you see this number will always be positive because it is squared. And beta is a real number as was given in the problem. So it means that this together with a minus 7 will always be less than 0. And therefore the square root will not exist. So there is no real root of x. That's why the answer C was 0. Question number 5. For question number 5, you were asked to indicate which of these 5 answers was correct. Given that x is a number that lies in the interval from minus 1 to 0 exclusive. So these are open intervals. So minus 1 is not part of the interval, and 0 as well. So that actually means fraction numbers that lie from minus 1 and 0 exclusively. So if that is true, what I would have asked you to do is, because this is an interval, range of values means all the values there must satisfy. If it works for all, not only for one. If that was the case, you are just left to choose one number and try. So for example, a possible number in this interval, you can guess yourself, will be minus half. So if I take x is equal to minus half, then I can try here. If I put minus half here, minus half plus 1, this is half. Because all of them had the same expression. So if you do it once, you can already just check. Here, minus half square is 1/4 plus 1. And that's 5/4. And here, minus half plus 1 is half. Half squared is 1/4. So if we check that here, you see that this is greater than that, but it's not smaller than this. So A doesn't work. Half here. Half is smaller than 5/4 and is greater than 1/4. So this is okay. There was no need to check the other ones. That's why B, there was the correct answer. Question number 6. Question number 6, we were given this equation and you were asked to look for the number of values of x if x is a real number. So if that is true, we're supposed to look at this and try to solve. Of course, you can start by trying to open that, expand that to the second power, expand this and try to solve and do all that. That was not really the idea in this question. The skill here was supposed to be that whenever you square a number, it's positive. If I square a number and I add it to another number that is squared and I get 0, it means that is only possible if the numbers are 0. Otherwise, it's not possible. So if I square two numbers and sum them up and get 0, that can only be possible if both numbers are 0. That means this is only possible if x minus 4x minus 5 is equal to 0 and x squared minus 3x plus 2 is equal to 0. To solve this, we can just factorize. I get two factors here. I look for factors of minus 5, which when summed up will give me minus 4. That's minus 5 and 1. So that x times that is x minus 5, and that gives me that. So I have two factors here. So this is x minus 5 times x plus 1 is equal to 0. And you see, I'm not saying, oh, they must be together 0 for this to work. I can also do the factors of this. Is x there, look for this. This is because this is minus 3, I will take the minus factors of 2. That's minus 2 and minus 1. If I cross multiply, that just like that. Then minus 1 times that is minus x minus 2x, that's minus 3x. So these are my factors. So this is x minus 2, x minus 1 equal to 0. From here, if two numbers multiply to give 0, it means here x minus 5 should be equal to 0, or x plus 1 should be equal to 0. See, this is a product, not a sum like this. So x here is equal to 5, or x is equal to minus 1. And x minus 2 should be equal to 0, or x minus 1 should be equal to 0. That means x is equal to 2, or x is equal to 1. And if you check, the number for which this should hold should belong to this, and there is no such number. Here we have 5 minus 1, here we have 2 and 1. And you can try, take each of the numbers and try. You will see that if I take x equal to 1, it's not going to be 0. If I take 2, it's not going to be 0. The number has to be at the same time in this and at the same time, because we need just one x. That's why the answer was 0. There was no such number.